So, welcome back, and in this video, this is a special one for you guys. This is a special video for OCR students. This is going to be covering every single thing you need to know about paper 1, plus exam questions that I think that will come up. So sit back and relax. I'm joking, don't sit back. Make sure you are taking notes. Make sure you're doing the questions that come up, and yeah, hopefully you enjoy this one and find it useful. So if you did, like, subscribe and comment and share with everyone. Let's get this channel to 1K, guys. Come on. System architecture. So this includes the CPU components. So here we have the components. So ALU, arithmetic logic unit, is basically what takes care of the addition, subtraction, multiply, division, all your NOT gates, AND gates, XOR gates, all the operations are done in the arithmetic logic unit. Control unit coordinates the activity of the CPU by sending out control signals to synchronize how data moves around the parts of the CPU. And it also takes care of decoding instructions. Cache memory is most frequently used instructions are copied there so that it reduces the time needed to fetch instructions from the RAM. This is a very expensive type of memory. However, if you increase the cache, the processor does not need to go into the RAM to find the instructions. It can use the cache to quickly find the solutions. And registers, these are memory locations which you can store temporary data and can be accessed very quickly. Von Neumann architecture. So architecture refers to how memory is the layout. So there are 4 main registers which you need to know. MAR, which is the memory address register. Make sure you use the hint in the name to find out what it's actually supposed to mean. So this basically stores the address of the data to be fetched from, or the address where the data is to be stored. Memory data is the actual data itself, which is being read from memory or is about to be written to main memory. Program counter, remember that it increments by 1 so that it can hold the next instruction in the FDE cycle. And we also have an accumulator which stores the results of calculations. Now we move on to the FDE cycle. Although you're not supposed to know the how the registers work in the FDE cycle, so this just helps you remember like what the registers actually do. So program counters, we know that the next instruction is copied from here and placed in the MAR, which then is copied to the MDR, and then the program counter is incremented so that the next instruction can be held. The decode is the MDR. It now contains the data, which then this control unit decodes, because remember from the previous slide, that's what the job of the CU is. And execute is performed by the ALU. Let's talk about CPU performance. There are 3 main characteristics. Clock speed, which is basically like every tick represents 1 step of the FDE cycle. Typical exam question is maybe 2.5 gigahertz. What does that mean? We can say that 2.5 gigahertz is around 2.5 billion instructions per second. The faster the clock speed, meaning that the faster the FDE cycle can happen. Also, the cache size, the more cache, remember, it doesn't need to go into main memory to find the instruction. The number of cores, so each core can represent fetch and decode execute instruction independently. So if we have more, that means 4 times as more. So like in a quad core, we can do 4 FDE cycles at the same time. It is only possible if the software can handle using take advantage of the multiple cores. This is a typical exam question. Embedded system. What is embedded system? It's a system that is designed to do a dedicated function. For example, a dishwasher only handles washing the dishes, washing machine only handles washing clothes, and also here. It's not a generalized system. A general purpose computer is like a laptop or a phone. These are not embedded systems. Make sure you know the difference between them. And they're often manufactured as a single chip, small little circuitry, low power consumption because it's only a dedicated thing, and it's small in size and low cost. And let's move on to the exam question. So Pause the video here and try and have a go at these exam questions. Stores the address of the next instruction. It's the PC, the program counter. What does the CU do? Coordinates the activities of the CPU, decodes instructions. And what stores the address? Remember, the address is a keyword, so MAR. And what performs mathematical calculations? The arithmetic logic unit. A car comes with many embedded systems, for example, parking sensors. So they gave you one example. We need to find another embedded system that is found in a car and explain why this is an embedded system. What specialized things do cars also do? So new cars, we have auto park features, lane assist, or the auto lights. So auto park is one of them. And the reason why this is a embedded system is because its only job is to handle parking the car. Is something that we can say. So like a dedicated function. Apologize for the handwriting, but hopefully you can make out what I'm trying to say. And part C, Alicia says my computer has a quad-core processor, so it will run twice as fast as a computer with a dual core. Technically that's correct. However, when is this not true? This is not true. Remember, we talked about this. Software may not be taking advantage of all the 4 cores. And we can also say that there are other factors. So one of them is clock speed, and that would give you the full 3 marks. And now we need to tick a box whether the smartwatch or a laptop is an example of an embedded system. It's actually a smartwatch. Why is a smartwatch an embedded system? Because a smartwatch has a dedicated function and is not a general purpose computer. Perfect. Now let's move on to the next topic, which is memory and storage. So this is a primary storage topic. So a computer system needs primary storage for any data that needs to be accessed quickly. This includes the startup instructions, the operating systems, and programs that are running. So the main difference between RAM and ROM, you should all know, random access memory is required to hold the operating system application that are running and any associated data while the computer is on and in use. It is volatile, meaning that it needs electrical power to operate. Any data stored in RAM is lost when it's turned off. This is key. ROM stores the BIOS, which helps boot the computer, meaning start it from scratch. And it's non-volatile, meaning that when the electrical current is stopped, it still maintains its contents and it's only read-only, whereas this is read and write. And here are some examples of questions that can come up, and we're gonna quickly answer it. So state the difference between RAM and ROM. One is volatile, one is non-volatile. Which one's which? RAM is volatile, ROM is non-volatile. That's 1 mark. 2 examples of data that the smart television could store in RAM. That is the video that's currently being watched, perhaps that is stored in the RAM, and another is part of the operating system that's currently running. Over here we have stores the boot up of the sequence. Remember, boot up is to do with the ROM, and the contents are lost when the thing is turned off. That is RAM, because RAM is volatile and holds a copy of open maps and routes. So this is things that are currently running, which is also the RAM. Now we move on to virtual memory. And why do we need virtual memory? Well, sometimes the RAM is not sufficient to store everything that's held. For example, if we're running complex programs and have lots of programs open, it may be inefficient for the RAM to hold all of them. So in this case, the computer can allocate secondary storage to act as a RAM. It does this by selecting data in the RAM that's not currently required in the CPU, and it moves it to a temporary section in the secondary storage. Once the data is required by the RAM, it's moved back from storage into the RAM. And this process is very slow. As you can see, this is a drawback. So using virtual memory slows down the performance of the computer. A way to increase the performance of the computer is to add more RAM. Adding more RAM means that there's less time wasted from going back and forth from the secondary storage to the RAM, whatever I just said. And this just recaps it in. Now we move on to secondary storage. And what secondary storage is that it's needed to store files and programs. It needs to be non-volatile because it doesn't lose data when it's switched off. And three things that we need to take care of when describing are low cost, high capacity, and reliability. So magnetic storage, these use like magnetic disks that rotate. You don't need to know in this detail, but you need to know that it has moving parts. And why is this important? Because it's not very portable. Because if you're using a hard drive on something that requires transportation, if you drop it, it's going to break. So that's why HDD aren't very portable. However, they are reliable and cost effective and provide high capacity at low cost. However, in solid state storage that uses a memory called flash, and there's no moving parts. This already means that it's very portable because there's no noise, there's no heat generated, none of that, and it's robust, lightweight, and compact, making them ideal for portable devices. So like laptops, some laptops have HDD, but most of them have SSD nowadays, and the cost of unit of storage is high. This is something you need to know because it's very expensive. SSDs are commonly used in tablet computers and mobile phones. And the third type is optical storage. These use light rays and they reflect off laser and by reading off ones and zeros. So because it's using laser light, these are easily damaged by mishandling and scratches. Now let's move on to some examples. So explain why a digital video camera needs secondary storage. What's the point of secondary storage? Well, it's to store files that need to be accessed when the camera is off. Explain why SSD is the most appropriate. So here you would say that hard drives have moving parts, making them less portable, and SSDs don't have any moving parts, so it's more portable. We can also say that it has a larger capacity. Videos need large capacity, so SSDs have enough storage, and it has fast read and write speeds. Explain why a computer needs both primary and secondary storage. So primary is to store active data, active programs that are currently running. Secondary is for long-term use programs. For example, like videos and images that you need to access later. Give an example of secondary storage. So we can say hard drive, which can store the artist's pictures. Make sure you relate it to the scenario, which is an artist. Now we move on to units. So computers use switches. As you know, there's circuitry, and these switches have two states, on and off, either represented by 0 or 1. And that's why we are interested in binary numbers. So each stored bit, binary digit, is called a bit. So usually we have 8 bits, which is called a byte. Make sure you know your difference between bit and byte. And a half of a byte is called a nibble, which is the smallest thing over here. And if you have 2 nibbles, that equals a byte. And this is the conversion table. Make sure you know how to do this. Also, it is important to calculate the required data capacity. So to do this, we get the estimated file size using these 3 formulas, which you should all copy down. The likelihood of these coming up, very high, and make sure you know what these mean. So now there are 2 exam questions, and how would we do the first one? Well, when we're conversing between the file sizes, make sure you convert to a standard size so each of them are on the same level. You should get the first one and the third one, which are the same. Convert these into kilobytes so that we have 80 gigabytes equals 80 million kilobytes, and each video is 200. So we do 80 million kilobytes divided by 200,000, and once we do that we should get 400 videos. Now we move on to data storage. So denary is in range 0 to 255. Hexadecimal is in the range 00 to FF, and binary is from all zeros to all ones. Left shift is the same as multiplying by 2, right shift is the same as dividing by 2. Overflow error may happen when you're adding two binary numbers up. There's a carry bit or a leftover bit. The leftmost significant bit is the most significant bit, and the rightmost digit is the least significant bit. We have a table which beautifully summarizes the conversions. We can basically use our knowledge that when you have an 8-bit, you can split it up into two nibbles. So the first part is 2, and how do you represent 2 in a nibble is just 1 0. And how do you represent 1, which is 1 0 0 0. So the answer here is 0 0 0 1 0 0 1 0. And this number in denary is 1 2 4 8 16. 16 plus 2 is 18. To convert denary to the binary, we basically create this table, and once you add in the values, you should get 0 0 1 0 1 0 0 0. Right, to convert this into hexadecimal, we split this, so it's here, and we get 1 2 4. 4 plus 2 is 6, so 6 goes on the right, and on this side we have 1 2 4. 4 plus 2 is 6, plus 1 is 76. That's the number in hexadecimal, and we can do the same thing here, which we get 1 2 4 and 8 on the right, and on the left we have all of them, which is the maximum, which is 15. And remember that the numbers from 10 all the way to 15 represent the letters A, B, and all the way to F. And because this is 15, we have F here, which is F8. And if we put the table, so 1 2 4 8 and so on, we will get the denary value to be 248. And we can have a go at this one as well. When you add two numbers, when it's 1 and 0, that's the same as 1 1 1 1. When you have two ones, that's the same as 2, but you represent binary 2 in binary as 1 0. So we have 0, and then we carry that 1. Now we have 1 1, and we have 0, and we carry that 1. Then you have 1, and then you carry the 1, and then at the end you have a carry bit. Make sure you show your carry bits, because that's often students leave out, and you leave out a mark. So this is called a overflow error. That's when the number that you're trying to add does not fit in the 8 bits, and you have a leftover bit. Characters. So each character is represented by a numeric binary code. The character set of a computer is a list of all the characters available to the computer. ASCII is a 7-bit code, represent the English alphabets, numbers, some symbols, and some control characters. There are 128 characters available. Extended ASCII has a 8-bit, so it has an extra symbol, mathematical symbols, and non-English characters. But there's only a limit of 256. Unicode has 16-bit, which is 2 to the power of 16. This should be a power, or this many characters available. And now it's been extended to represent billions and trillions of characters. And let's do a quick exam question. Explain how the word mop is represented in ASCII. Given the ASCII code for the character, so for mop is 77, then for O is 79 and 80. So what happens there is that we basically 77, 79, 80 in binary into an 8-bit binary number, and we just put it together. And once you do that, you should get some long binary number. And over here, we have to tick the character set which these belong to. So what can represent thousands of different characters, including Russian and Chinese symbols? Well, Unicode is the only one to do multiple languages and symbols. So that's Unicode. And can represent European characters such as these symbols. So European characters, we can also use extended, and whatever is part of extended is also part of Unicode, because everything is like a subset, and also uses different character codes for uppercase and lowercase. Well, every single one of them does it, so every one of these would be ticked. Hopefully that clears up some misconceptions. And now we move on to images. So images, the key word that you need to know is pixels. Pixels are stored in a computer as binary codes, and images are represented on the screen as a series of pixels. The number of bits used for each pixel determines how many colors each pixel can represent. With 1 bit, we can only have 2 possibilities, because in one you have 2 options, 0 or 1. And to store more than 2, we would need to use 2 bits. So 2 bits, we have 2 to the power of 2, which is 4. So we have a color 4 possibilities, and 3 bits, we have 8 possibilities of 8 different colors. Make sure you know how to calculate bits, and also metadata is information that tells the computer how to reproduce the image. It usually contains color depth information, resolution, maybe geographical location, when the image was created, things like that are all stored in metadata. And here are some exam questions. And the binary data stored for the data is given here for the image. And we're told that the table red equals this value, and how many bits are we using? Well, we're using 4. So we basically just divide this up into 4 parts, and the corresponding we write over here. So the first one is going to be red, then the second one is going to be red, then the third one is going to be red. And we just put the corresponding colors here. Now state the maximum number of different colors that can be represented using 4 bits. Remember, we just put that to the power of 2. So 2 to the power of 4 is 16. We can represent 16 different colors, and the color depth is increased to 2 bytes. Remember, bytes. Straight away we would increase the file size because we're storing more bits, and we're also improving the quality of image. So that's 2 effects that can have. Over here we have state what is meant by image resolution. What is image resolution? Is the number of pixels in a image. So in this case it would be 1, 2, 3, 4, 5, 6 multiplied by 15, which is 90. And so calculate the fewest number of bits that we need to store this logo. So how many different colors are there is the first question you need to ask. 1, 2, and 3. We only have 3 colors, so the minimum that we need is 2 to the power of 2, which can store 4 colors. Usually students would say 2 to the power of 3, that would have 8 colors. We don't need that because it's asking for the fewest number. We need 2 to the power of 2, which is 4. Sound is a series of vibrations that continuously vary and can take any value. This means that they are analog, and in order for the computer to store sound, we need to convert this into binary. And how is this done? Well, we sample at regular intervals by a device that converts analog to digital, and the sample rate is the number of samples taken per second, measured in hertz. 1 hertz means 1 sample per second, 2 means 2, and so on. The duration is the length, and usually in seconds, and the bit depth is the number of bits used to store each sample. File size depends on the frequency of the sample is taken. For example, if we take it more frequently, it will have a larger sample rate, meaning a higher file size. And also, the greater the bit depth, the more data is stored, and therefore greater the file size. Here are a few questions. Explain how sampling is used to make the recording. The amplitude of the wave is measured at set intervals, maybe every second, and it's stored as a binary, and which then creates a approximated sound wave. State the effect of increasing the sample rate. Straight away, increasing something will increase the file size, always related to file size. Therefore, what does that mean? That means we're going to have a better sounding or audio. Also, what is meant by the term sample frequency? This is the same as sample rate. And over here, we're going to have increasing the sample frequency. We're going to have the file size will be larger straight away. So this one. And the quality will be better hence. And we move on to the next one, which is your compression. So what's the need for compression? Compression basically makes the file smaller. We have two options to making a file smaller. We have lossy and we have lossless. Lossy means that data is removed to make the file smaller. Algorithms remove data that is least likely to be noticed. And for example, we use this in images because users cannot tell, unless you're pixel peeping, no one can tell if a picture is missing detail or not. Also, lossless is meaning that none of the data is removed. The way that this works is it looks at patterns and it groups together the patterns. You don't need to know that, but it's good to know. And also the original file can be restored. However, in here we can't. So this would be good use in text files. So this basically recaps what we just said. A student needs to reduce the size of an image and a text. So what is the most suitable compression for text? As we discussed, this is going to be lossless. Because if we do lossy, some of the characters are going to be messed up and the file may not even open. Identify the most suitable compression for image. So this is lossy because image will only lose quality and changes will not be noticed by the user. Now we move on to computer networks, connections and protocols. First things first, make sure you know the difference between a LAN and WAN. So LAN is a local area network. It consists of devices connected together in a single building or site such as school using Ethernet and wireless connections. WAN is a wide area network. It's formed by connecting multiple LANs. It can spread across a wide geographical area, sometimes continents, and uses third-party communications. So in LAN, they use first party. It's usually owned by the company which they're there. And in here, they use third-party communications. And an example of WAN is the internet because it's connected via the LAN. Client server means that there's a client and it's connected to a main server. The advantages of this is that all backups, files stored centrally, activities can be managed, and however the drawback is that if the server stops, everything is stopped. Servers also are expensive because the hardware is expensive. Also, we need specialized technicians that know what they're doing to operate servers. Not people like us can operate it. Peer-to-peer, all computers have equal status and are connected directly. Computers store their own programs and files. A plus point is that no single point of failure, as there is with a client server. There's a server, if that fails, everything stops. Here, there is no single point, and also a drawback is that there's no central management. So all the updates, all the file backup, everything has to be done on each individual computer. Bandwidth is the measure measured in megabytes per second and refers to how much data can be transmitted over a network in a given period of time. One characteristic of LAN is that they are set up over a small geographical area. Give one characteristic. Another feature is that it uses their own hardware and own software, uses internal hardware and no third-party infrastructure. However, on this side, we have one characteristic of a WAN is that it's a large geographical area. Give another characteristic of a WAN. So another characteristic is that it uses third-party telecommunications, like third-party hardware. Also, describe one benefit of the supermarkets using a client server instead of peer-to-peer. Remember, with questions like these, you have to apply it to the actual question. So what we can say here is that all files are stored centrally, so workers can access files from any computer they want. Now we move on to factors that affect the performance. There are three main ones: the number of users. The reason why this affects network is because the available bandwidth is shared. So if we have maybe 100 megabytes per second as the bandwidth and we have 10 users, we divide that by 10. Each person is getting 10 megabytes to do whatever they want. Hence why 10 is probably not enough to watch the video that you're trying to watch. Also, what affects network is the transmission media used. So for example, wired or wireless. And in wired, we have three or two cables which we need to know. Copper cables are between 100 megabytes and 1 gigabytes. bandwidth, and copper is more cost effective. Fiber optics have a very high bandwidth, up to 100 terabytes, and capable of transmitting data over 100 kilometers or even larger distances. And also, error rate is another factor that affects performance, which is when there is a lot of traffic on the network, it can result in transmission errors due to packets colliding. And radio waves are used in wireless, so that again is the transmission media used. So with wireless, so Wi-Fi and Bluetooth, they use radio waves, and radio waves always have interference issues. So here is a typical exam question. So explain how each of the following can contribute to performance of network. So with Wi-Fi frequency 5 gigahertz will have more data per second than 2.4. Interference is like an object can block it. The number of users means more traffic using the same bandwidth. Bandwidth is shared. And type of network traffic, which refers to what type are we trying to do. So like streaming, downloading, or things like that. Identify one other factor. One other factor we can say is the error rate. Now, explain why the number of devices more devices can affect the performance. Well, we've kind of already talked about that. So make sure you know your WAPs. So a WAP is a wireless access point, which helps connect users to the network. So this broadcasts an SSID so that Wi-Fi devices can connect to it. The WAP is usually connected to the network via a network switch via cable. However, WAPs can also use as a range extender. Switches is a piece of hardware that allows multiple devices to connect together to form a wired network. A switch stores the MAC address of each device connected to it, and the switch receives a packet of data. It looks at destination address and forwards it to the intended service, similar to a router. So a router is a piece of hardware that connects networks of different types together. Commonly, it's used to connect the LAN to the internet. So for example, in a home, that's what it's used for. The router itself actually receives the IP address and forwards it to the corresponding location. So they collect data about all the possible routes and finds the most efficient and appropriate route to send the data packet to. So identify one hardware device that would be needed to connect the laptops to the internet. So straight away, a router can help that. And two other additional pieces, so NIC and WAP. So NIC to connect, use an Ethernet cable to connect to the internet, and a WAP to extend the range or to allow wireless connectivity. Identify 3 tasks carried out by a router. What does a router do? Well, it receives data packets, that's number 1. Number 2, it forwards it. And number 3, it finds the most efficient route that the packets can travel. That's 3 things that the router can do. And explain how wireless access could slow down the network. So wireless transmission is slower than cabled. We all know that. More devices can be connected, increasing the traffic, reducing the bandwidth available for each user, and there might be interferences such as walls. Alright, the next one is the DNS. So what is a DNS? It finds the IP address for the corresponding domain name, and websites are hosted on web servers. Client computers request files from a server. When you visit a website, the browser on your device requests a web page which are downloaded to your device. This is what the DNS does, and this is how it works behind the scenes. And what is the cloud? The cloud is held for, like, files and applications can be accessed from anywhere that has internet connection. So what are the plus sides of the cloud? So the examples of clouds are like Google Drive, OneDrive, all of those cloud operating systems. So what's the benefit of those? Those are beneficial because files can be accessed from anywhere. Users will have the most up-to-date version and don't need to update anything, or they don't need any technical staff to handle this. Anyone can do it. And the amount of storage is flexible, meaning that they can buy more if they want to and not like have physical hard drives. The downside is internet connection is required. Users have little control over security because it all depends on the platform that they're using, and providers can change the terms and price with little notice. And here is a advantage that we just discussed, and Explain how the URL is converted to the IP address. So the URL is sent to the DNS finds the corresponding IP address and returns the IP address. If there's no corresponding IP address, then it sends it to a higher level domain name system. Now we talk about star and mesh topologies. So star network is each computer is connected to a central point, which can be a server or a switch. This is fast and reliable because each client has its own connection to the central node. Data is only directed to the intended computer. It helps network traffic to a minimum. However, it requires a lot of cabling because each client is connected individually, which can be expensive. Also, there's a single point of failure, meaning the server or the switch, if it fails, everything is gone. Students, what typical things that they struggle is that they think that it's the same as a client server, whereas it's not. Because in the star network, it could run applications in either client server or a peer-to-peer model. So meaning that we can have a peer-to-peer and still have a star network as long as all the pairs are connected to a central hub. This is commonly found in schools and businesses, and a mesh network is that every device is connected to every other device, commonly used in a wireless network. The point is that there is no single point of failure, and it's used when network communication is very important. So for example, the military and the emergency services will use this. And if any component fails, data can simply use another route. And because everything is connected interconnectedly, you can just use a different route to reach wherever you want. However, it's too impractical and expensive to set up because it requires a lot of maintenance and owning too many connections. These look similar to peer-to-peer. However, a mesh topology can also support a client-server model where one of the devices is a server. So we can have servers connected to other servers. However, in a star, we have a central point, which is a key difference. So here's a typical exam question. And the way that we could do this is we connect each to each of the items, and every other computer can be connected to every other device. And two reasons why a bakery might want to use a star network: because we can add new clients easily. Also, we can if a device fails, it won't affect the rest of the network. Now we move on to wired and wireless and protocols. So protocols are a rule or a standard that must be followed when data is sent between devices or a network. Make sure you know your definition for protocol. There are three main ones. So Ethernet is a protocol used to connect devices in a wired LAN. So the Ethernet cable is like a standard cable that everyone uses. Wi-Fi is a set of protocols to define how to communicate wirelessly using radio waves, using either 5 gigahertz or 2.4. And we have a third one, which is Bluetooth, which can be used over a short distance using ultra high frequency radio waves. And here are some of the most commonly used protocols and the functions, which everyone should know. So here's some exam questions. Requesting to view a news web page from a web server. This is HTTP or HTTPS. Entering a username to access bank account. This requires secure and encryption, so we use HTTPS. Downloading a text document from a web server. We're accessing a web server that is HTTP or HTTPS. And checking for new email in the index box. Which are we going to use? We're going to use POP. Now tick one box in each row to identify whether it's Ethernet or Wi-Fi. A wired connection is Ethernet, more likely to be affected by interference, that's Wi-Fi. Data can be transmitted at a faster speed, that's Ethernet. Wireless transmission is Wi-Fi, and shorter transmission range before data is lost is Wi-Fi. So make sure you know the difference between Ethernet and Wi-Fi. Now, Ethernet is a protocol, that's true. Ethernet uses wireless transmission, that's false. Ethernet can transmit data speeds up to 100 gigabytes per second, that's true. And the last one is you don't really need to know that. And explain why Ethernet is a standard. Why is Ethernet a standard? Well, if it wasn't a standard, we would need different cables to connect to the internet. Well, we have one Ethernet cable so that all manufacturers and to allow compatibility between different devices. What's the difference between an IP address and a MAC address? Every device connected to the internet is assigned a unique IP address to enable it to be located where it is in the network. IPv4 used 32 bits broken down into 4 8-bit sections, representing a number between 0 and 255. This was part of a question, and IPv6 uses 128-bit number, which is broken down into 8 16-bit sections and written in hexadecimal. MAC address is used of 48 bits and is used on the specific hardware side of things and cannot be changed. Once it's set, is set. And that's basically what you would say in this question here. Now we move on to layers. So what's the point of layers? Well, protocols are assigned to layers, each of which has a specific purpose to enable communication to take place. When data is being sent, it passes through each layer in turn and is encapsulated with more information. When a data packet is received, each layer of information is read and decoded in reverse order. This refers to this TCP/IP stack, which you don't really need to know, but it's a good example to get the idea of layers through. What are the benefits? Well, one layer can be developed or changed without affecting other layers. Also enables hardware and software manufacturers to develop different products that will work together. And it's easier to identify and correct networking errors and problems. The next 1.4 is network security. There are several types of malware. We have virus, which is like deletes and corrupts file. We have worms, trojans, and for this, the way that you would prevent malware is to install antivirus or anti-spyware software. Make sure that the operating system is up to date, and also implement user access levels to prevent standard users from being able to install software, and educate users about the risk of opening. There are other threats and prevention. So for example, social engineering is when you trick someone and in order to give critical information. Methods include phishing, pretexting, and shouldering. Ways to prevent are to educate the users so they know that this is a fishy email, or they know that someone is probably looking at their shoulder. Also, brute force attacks involve like use of automation systems to crack passwords. They try every single password until it's correct. So the way to solve or prevent this is to limit the number of use attempts required for like a password. That's why when you attempt too many, your account gets locked. That's a way of preventing. Denial of service attacks occur when a server is flooded with too many requests. A way to prevent it is to install a firewall to reject packets. Another one is SQL injection. This is when you write SQL queries into a text box. A way to prevent this would be to use input validation and set password and username rules so that you can't write SQL in the text box. Also used input sanitization to remove special characters. So for example, you can't write select or from or stars like that. Also, network packet sniffing can also be taken place. To prevent packet sniffing and data interception, use strong encryption, especially on Wi-Fi networks. Do not use public Wi-Fi networks, and use MAC address authentication on networks so that only known devices can connect to it. Also, penetration testing is used to identify weaknesses and vulnerabilities in the system so that they can be helped. Here is a question that can come up. So spyware, what is the prevention methods? Well, anti-malware or firewall would help. For brute force attack, make sure you're doing penetration testing to find vulnerabilities, and also use a firewall. Data interception, again, we can use encryption, and for SQL injection, we use pen testing or firewall. Now we move on to 1.5, which is system software, and in this topic, we're going to be talking about what the functions of the OS are. So it firstly creates a user interface to allow the users to interact with the system. Memory management to control the use of RAM. So for example, like virtual memory. That's an example of memory management and allows for multitasking. There's also peripheral management, which is like peripheral devices such as drivers, and driver acts like a translator to allow the CPU to communicate correctly with the device. User management to control who can access, and also file management to add folders, subfolders, and this is basically what we just discussed. Utility software is a collection of programs that does specific housekeeping tasks to maintain a computer system. There are three main ones you need to know. Encryption software, which is used to encode data so that it cannot be understood even if it is found. So it uses like an algorithm and public key, private key, and you need the key in order to decrypt it. Defragmentation, which over time data on a hard drive become fragmented, parts of the file are saved to different areas, and it creates like blank spaces in the hard drive. So what defragmentation does is that it reorganizes the file, putting all the free space together and all of the parts, all of the same files together, which improves performance and helps find the files easier. The third one is data compression. So again, we've talked about lossy and lossless compression, which basically just reduce the file size. State the need for utility software. Well, utility software perform housekeeping tasks to maintain the software, and explain how the restaurant's hard disk could have been fragmented. Again, link back to the question. So what would restaurants be storing in the hard drive? We would probably be storing a lot of orders numbers, all of that. So once a new order is made, you probably delete it and keep making it, deleting it. So that can be one of the reasons why it can become fragmented. Make sure you can apply it to the question and explain how defragmentation can overcome the issue of slow computer system. This is basically explaining how it works. So how does it work? It collates free space together and files are moved to stored together. Now we move on to the final topic, which is ethical, legal, cultural, and environmental impacts of digital technology. Ethics refers to what is right and wrong. Legal issues are like laws, and there are main things that you can read here. Cultural issues refer to like ideas, behaviors, beliefs of various groups of people. Cultural issues relate how computers have impacted our lives. Environmental issues can be separated into two, negative ones and positive ones. Negative ones are like e-waste and using non-renewable metals and materials and using some toxic materials. Positive ones are that like introducing home working, work from home, which reduces the CO2 emission. More on-screen documents like PDF ones reduce the use of paper and other resources. And privacy issues refer to what is being like monitored. So for example, CCTV, ANPR, websites that track information. This is to do with the rights of an individual and how it's broken. So there are three legislations which you need to know. Data Protection Act, which has these following principles. We have a Misuse Act, which is basically if you misuse a computer, like including hacking, distribution of malware, this is like misusing the computer. And we have a copyright to which protects the intellectual property of an individual, so that you can't just copy someone else's work and use it as your own. We have proprietary software, which is written by organizations to make profit. This is key. And the source code is kept securely so that you can't just use it and create your own. This is copyrighted and it needs to be licensed for a specific fixed number of systems. Open source uses like a community of developers. Software developed under open standards make the source code available to everyone. So with proprietary, source code is hidden. With this, it's actually open for developers to change and modify it. And yeah, hopefully you guys found this useful, and be sure to drop a like, drop a comment, and yeah, I'll see you in the next one.